Welcome to CrystalMaker 11. This tutorial introduces you to the MOF Automation feature, which we added in version 11.7. Metal organic frameworks, or MOFs for short, are complex three-dimensional networks arranged around large cavities. Our new automation feature aims to simplify the process of depicting these topologies. Let's take a look with MFU4L. Here we see a typical MOF framework. It's a complex model that's a bit hard to digest. As the saying goes, you can't see the forest for the trees. Let's try tidying this up using our new Automate command, available on the Transform menu. It's not just one new command, it's actually a sub-menu of commands, and we're going to use the Filled Rings and Cavities command. You can see the two stages in action here, identifying the organic rings, colouring them in, and then the size and positions of any cavities. Now let's take a look at the new sites generated by the program. And you can see these listed in the legend. C2N3 ring in pink, C402 ring in green, C6 ring in blue, and then the cavity, which has been labelled with its radius, 10 angstroms radius. So we have three symmetrically distinct rings plus the cavity centroid. Now this is clearer to see if we navigate to the Atoms Inspector, and we have a new dummy site with chemical element ZZ listed in the inspector. And here again are the C2N3 rings, C402 rings, and the C6 rings, and we can label those and toggle them on and off as we need. And last but not least is the cavity site, here shown as a translucent space filling sphere, and you can always use the measure tool to check that the radius is indeed 10 angstroms. This is a 20 angstrom diameter cavity. Now we should note at this stage that although this still looks a bit like a ball and stick plot, it's actually one of our polyhedral models. This is actually our most flexible model type and allows you to combine ball and stick, polyhedral and space filling styles all in the same model. Now I'm going to stylize this even more so we can understand the framework better. We'll start by hiding the cavity, and we'll simplify how we show the ring atoms. So our carbons, which are shown as a ball and stick style, we'll just show using a stick style. The chlorines, which are vertex atoms on the cobalt polyhedra, we'll show as blank. The nitrogens we'll choose a stick style for, and the oxygens we'll use blank. That's now a rather simpler representation of the structure, allowing us to start to see the forest for the trees. And I'm going to go one step further, and I'm going to use solid polyhedra for the cobalt and the zinc polyhedra. Now we can see the rings and the cavities better. And this structure is made up of a series of organic struts that are connected together by metal joints. Let's focus on one of those struts. So I'm going to use the arrow tool from the tool strip, and I'm going to shift click on 1, 2, 3, 4, 5 rings. Let's isolate those Let's hide the unit cell, and we'll auto scale that and set that off spinning. So here are the 5 organic rings that make up one of the struts that holds the large cavities open. Now let's focus on the metal connector unit. So I'll select the central zinc, and let's take the 4 cobalt tetrahedra around that, and let's isolate that, hide the unit cell, and auto scale that. And we can change to other model types to highlight that geometry more clearly. So that's a quick look at the MOF automation introduced in CrystalMaker 11.7, which provides a stylized view of the structure. We hope you find it useful.